Hi everyone, welcome back to another video. So in this video, I'm going to be going through my first real kind of circuit for my final year project. And it's a super basic one, but it's something and it works. And I'm very happy with it. So if you don't know already, I'm making a renewable energy educational kit whereby I want to make a solar charge controller and then have that be powered by a battery, solar panel, and then obviously the solar panel charges the battery. But I want it to be a kit whereby the person solders it together themselves and they actually can go through tutorials exactly on, how the charger works and how that whole circuitry works. And I don't really know how it works right now. I've got about 6 months. I've got 6 months to do this project. Realistically, I've got to do it in the next 3 months. So this is going to be a fat grind, but let's go. So the first circuit I've got here, which would be the first tutorial, is can we get it so that when our battery, whatever battery it is, so my supervisor advised me to go with nickel metal hydride, even though they're actually really complex to charge, they're a lot safer than using, like, for example, a LiPo battery, which if you short this out, it will explode. And so if it's going to be an educational kit, it probably makes sense to go with a nickel metal hydride one, since people can get those batteries anywhere. They're just bog standard rechargeable batteries, and when you short them out, nothing bad happens, which is a good thing, right? Especially if this is going to be sold to kids. So the first tutorial is when the solar charger in this configuration right now, the solar charger is currently charging battery. Okay, then when that battery reaches its full voltage, whatever I set it to be, and I figured the way that you can set the voltage is by adding resistors in front of the relay before the input voltage from the battery, and then that way you can increase the voltage at which it triggers at. So if I've got a 4.8 volt battery, currently right now this relay triggers at 3 volts. Stick resistors in front of it. I'm not sure how much it's going to be, but you can figure it out basically. And then this relay will trigger at 4.8 volts and then disconnect the solar panel. So the solar panel is coming in here at this input, and it's coming in here into the normally closed contact. And then what happens is once the 4.8 volts is reached and that's put across this relay, the relay trips, and then it sends to the normally open contact, which is just a resistor which goes to ground, and therefore it disconnects the solar panel from the circuit. So I've got the schematic here, which I did on multi-sim. So let's just go through how it works. You've got the solar panel here, you've got the battery here, and this is the relay. Let me grab a pen. Okay, so this is the relay. It's a bit awkward how they show it, but that's the relay there. So what you've essentially just got two circuits really. If we go through the first one, so here I've got a solar panel, and then there's a diode here which allows current to flow this way, right? And it doesn't allow current to flow that way, right? So the current from the solar panel is flowing, and it's coming through here, through the normally closed contact, because that's normally closed. Coming here, obviously this is open, so that it doesn't flow here. Comes back around here and into the battery, right? So you get a nice, let's go through that again. Here, round here, and into the battery. So the solar panel is connected directly to the battery, basically just goes via the relay. However, once that keeps on happening, let's say that the battery voltage starts at, I don't know, 2 volts. Let's just say that. As it begins to climb up towards that 5.2, or in this instance 4.8, whatever the battery voltage, it doesn't really matter. As that climbs up, eventually, since this voltage is along here, eventually it's going to trip the relay. When that trips, this connection becomes open, right? So then now the solar panel through the diode is now open, it's got nowhere to go. This one becomes closed, and then that just obviously just a resistor, just a ground. So yeah, that's how it works. It is a super simple circuit, and the purpose behind doing this is I want to start from this kind of circuit and build my way up towards the whole complete solar charger basically. So something like this. Which is mate, it's scary to think that you can go from like this relay circuit here and then go into like a full-on charge controller. But the hope is that let's say Obviously, I'm going to be restricted by time, and that's going to be a big deal. I've only got 6 months, right? But I can stop at any point from here all the way up until here, right? And so anywhere in the middle there, however far I get to come April, May, is good enough for me, right? So let's see how I do. I look forward to this. This is daunting though when you look at imagine what this schematic looks like. I mean, it doesn't look too bad, right? It's just a tiny little board. Yeah, hopefully we can do it. There are a lot like more simpler charge control. I mean, actually, wait, that's not very simple, is it? But using ICs and stuff like that will get better. But I just thought, you know, when I start off for my first tutorial, it would be nice to be like, okay, this is what a relay does. Then the next tutorial, maybe use a transistor, swap out the relay for a transistor, right? So you can be like, okay, look, you know, I think, like, especially if, for me, and I'm 29 years old, but, you know, for me, when you explain things like this using a relay, then go to a transistor, then go up from a transistor to an IC, it shouldn't hopefully be too much work for me. I just have to understand it first and foremost. But once I've understood it, like I've understood this, it shouldn't be too hard to just keep, you know, going up levels of abstraction and making it simpler. Like, you know, take this out and then chuck in a transistor. Do the same thing. Take that transistor out, or let's say transistors, 3 transistors plus a couple of relays. Take that out, put in an IC. That's what I'm thinking to go with this. So yeah, I look forward to this. This is my first disconnected. Actually, I haven't even showed you it working. Let me show you it working. Okay, one thing I forgot to mention was the diode. Obviously, the diode is here because what you don't want is that your battery, you don't want your battery to come, like if you come along here, you don't want it so that your battery is then going and leaking current into your solar panel. So that's why you put the diode there. You may want to remove it and not worry about battery leakage from the battery back to the solar panel, because obviously the solar panel is not drawing any current. So to be honest, I don't think the diode really needs to be there. And I probably, if I was to do this, probably in my final product, I'll probably remove that diode, because obviously it does have a voltage drop, which ruins your already low voltage that you're getting from, you know, these useless solar panels. They're tiny, right? So you probably don't want a 0.7 volt drop across the diode there. So probably might be best to remove that, but it's just there to stop backward leakage current. But again, I don't think you need it. All right, so let's go into, right, I'll show you. So I'm using my power supply here to simulate a battery charging, right? So you start off here at 1 volt, nothing happens. So currently right now the solar panel is still charging the relay, and I'll show that to you when not the relay, still charging the battery, meaning my power supply. And then as I crank up and I go towards 2.9, then this relay is going to trip. So it actually tripped there at 2.8. And then now, if I just keep going up, right now I can keep on turning up my voltage because obviously this is a power supply, but the solar panel is no longer connected to the circuit. So if I just crank this up to 20 volts now, well, I might burn out my relay, so I'm not going to do that. But this, so that resistor there is bearing the brunt of that 150 milliamps, and that resistor is hot. So yeah, it's that resistor there that's connected to the normally closed. This one here, this resistor here is the one that's bearing the brunt of all of that 3.6 volts. That's something to keep in mind there. You probably want to use a big chunky high powered resistor, but it's fine. Again, like I said, what would happen is you wouldn't have any current draw really, and your battery wouldn't continue going up. So what I want now is, if I'm going to be doing this battery, right, 4.8 volts, I need the relay to trigger at 4.8 volts, and I don't need it to trigger at its current 2.8. So currently when it's triggering at 2.8, that's not what I want. So what I'm going to do is I'm going to add a resistor, and I'll show you how to do that. Basically, I'm going to be putting in the resistor battery. Is that correct? Yeah. I'm putting a resistor in here. You can make it variable if you wanted to. So I'm guessing it's going to be like 100 ohms or less, sometimes a lot less. So I'm going to put a 100 ohm resistor there between basically the battery and the, oh actually no, silly me, I'm putting a resistor here. Don't mind me. So it's going between the battery and the relay. That would be between the battery and it's like the relay's middle port. I want it between. I want it across. I want to affect the voltage across the coil. Right. I just realized you guys haven't been able to see any of that. Apologies. So I want a relay here. Relay or resistor? Bloody hell, man. I think it's midnight now. My brain's like, mate, time to go to bed. Yeah, so I want a resistor right here between the battery and the coil of the relay. Cool, so let's do that. Okay, so I've attached a 47 ohm resistor between, so I've got my positive rail and then between the power supply and the coil, 47 ohms. So let's see what voltage it triggers at now. So past 3. Still going. Okay, so 5.5 volts. So we need something less than 47 ohms. So again, I just keep doing this now until I get the right. Just go down and down and down until I get the perfect resistance. So I've got a 22, a 10, and a 10, so 42 in total. And now we should be a lot closer. Over 4.8. So anything like under 5.5 would probably be okay. 5.2 there, 5.4. Okay. Alright, so this was 42. So 47 was too high, 42 is too high. We need to get a bit lower. And it should be done now. So 10, 20, 30, 40. So just 4 resistors in series go into the coil and the relay. And we should get just over 5 volts now, the trigger. 5 volts. There we go. So it's like 5.1, 5.2. But yeah, that's more than good enough. So to charge to charge a 4.8 volt battery, 5 volts, 5.2 volts is perfect. So yeah, I mean, you could even go, I think, like 5.6. So yeah, that's more than good enough. So now I would be able to just, like, for example, connect. Should probably have turned off my power supply. But I should just be able to connect my battery in here. Cool. Okay. And so what we can do now is I can just check what the current is coming from the solar panel. We'll check the voltage as well. And then, so right now, this solar panel is currently charging this battery. And then once this battery reaches 5.2 volts, the relay will trip and it'll disconnect the solar panel. Super simple circuit. I'm actually just going to remove that diode as well that I mentioned. Remove that and then just connect the solar panel. Oops. Directly into the relay, like so. Alright, so I'm expecting a tiny voltage because it's midnight, so probably something around 2 volts. 1.6, and then I've got a little light here. If I bring this light down, what do I get? 2 volts. Yeah. So 2 volts there, and then let's check the current. Alright, you're gonna have to excuse the annoying beeping from this freaking, I hate it. This is the worst the worst multimeter I've ever bought. Some smart one. Ugh, horrible. Doesn't actually have actual buttons. Ugh, anyways. So currently 1 milliamps, and then when I bring my light down to get it to that 2 volt threshold, we get 10 milliamps of current. So that's kind of in line with what I got in my last time I did an indoor solar panel, where I was getting 5 milliamps indoors at night time, and then just from my LED lights. And then when I put it on my windowsill during the daytime, even though it was cloudy, I was getting 40 milliamps. So I'd expect that somebody, if they stuck this on the windowsill, they should be able to get 50, 60, 70 milliamps of current. And so now, like this, it's charging. Obviously this is going to be very slow, like probably 3 months to charge this, but that's because it's a little crappy LED ring light, right? Just that's all it is. So you're not going to get any efficient voltage or current out of that. But yeah, so you can see, so like this right now, it's charging. Then if I now simulate, so I've got my battery here, I'm just going to connect back to my power supply and increase the voltage, and then we should see this cut off. Alright, so you can see here, you've got 6 milliamps of current on here, and my power supply is reading 0.5 volts, so 500 millivolts. So obviously my power supply is basically off right now, but there's some, that's the voltage that's being fed into the power supply, which is hilarious. Thankfully my power supply should be able to handle it. So as I crank up the voltage now, you're going to watch this 6 milliamps. It should drop down to 0 and even -1, -2 milliamps. So we're going to go up, and you can see already we're getting some fluctuations. It's gone up a bit, but now it's going to start going down. There you go. So 3 milliamps at 4 volts, 5 volts. It's at 0 milliamps now. You can see the relay is ready to switch. Boom. There we go. So now 5.3 volts, and now our solar panel is disconnected. And we're getting 0, -1, 0, -1. The beeping drives me nuts. It's well annoying. I got no idea what to do with it. Anyways, so that's it. That's the circuit. It's simple, man. And you know, it makes me sad that it took me weeks to get to this stage. Obviously, I haven't been focusing on this. I've been doing digital signal processing, and then I've been doing engineering control, which has been like flexing simulations and manufacturing and stuff like that. So I haven't really been doing electronics, which is frustrating because that's what I want to do. I want to do electronics. So I'm hoping now to put some real focus into this. I'm very happy that I've created my first kind of like tutorial video. I'm actually going to make an official tutorial video to come with the kit for each of the tutorials. But obviously, you know, this could I don't know. Yeah, I was gonna say that this could maybe serve as it, but no, let's not do that. But yeah, cool. So that's it. So all we're doing here, what we've done here is we've just added 40. Was it 40 ohms? Yeah, we've added 40 ohm resistor there. And so if I want to, for example, instead of it triggering, so at the moment 40 ohms triggers it at 5.2 volts. If I want to trigger it at, you know, 12 volts, I'll probably just add like 200 ohms or 150 ohms. So whatever, the resistor here is going to be small. One thing that might make a difference, which I don't need to worry about, because with my kit, I'm going to be including the relays as part of the kit anyways. But with your relay, whichever relay you're using, it's going to have the coil is going to have its own resistance. And that's obviously going to affect the value that you pick for your resistor. So you can come with this exact same setup, the exact same relay, but then you're going to have to just still adjust the resistor because of the relay's coil resistance. Yeah, and then obviously what the wires have their own resistance and stuff like that as well. But I'm planning for my kit to include every component in the kit already. So yeah, make it nice and simple for the person. So what I'm going to do is in my next video, I'm planning for my project to use like rechargeable nickel metal hydride batteries like this, because what I want is I want the person, I imagine like, you know, a family buys this for their teenage son or something like that, or you know, a 19-year-old, 25-year-old, 30-year-old electronics guy getting into electronics buys the kit. So if I can include something like, you know, a case with like 6 batteries in there where 7.2 volts, and then they can just, you know, pop out, go down to Amazon or whatever, go Tesco and buy their own batteries. Just, you know, something, because maybe like going for like this and them having to try and find their own LiPo battery and then worrying about the capacity and all the rest of that. I'm thinking nickel metal hydride, they can just go and buy their own rechargeable ones. That seems perfect to me. So yeah. Next video, I'm hoping to have a 6-way version of this. This is just 4 batteries. I'm hoping to get a 6 one, 7.2 volts. Do the same thing with this, and then start swapping the relay out with the transistor, and then go up from there. I think so. This would count as a 1-stage charge controller. What I want from here is to have a 2-stage one now, so that, for example, let's just run through it again quickly. So at 5.2 volts, it's going to disconnect, right? Okay, and then as it disconnects oh wait, you can't see my password. As it disconnects, what I want is, you know, as the voltage starts to drop now on the battery, let's say it gets to 5 volts, there should be a point at which the voltage should turn back on, and the solar panel should be connected back to the battery and should start charging the battery again. Using this relay, I think like you got like hysteresis. I don't really understand it, but as I go down, it takes a while before you're gonna hear the click again for the solar panel to be connected. So let's just watch. Two volts. That's so bad. So at that point there, you know, your battery is completely dead. So a one-stage charge controller is obviously completely useless if it's that bad, right? I was expecting 5.2 volts. I was expecting it to go down. Let me try to do it fast, right? So let's say we're at 5.2 volts. If I just drop it down quickly, no disconnect. No, still look, still holding. So yeah, in that instance there, I need to now create the next circuit whereby the next circuit we need a reconnect back to reconnect the solar panel back to the circuit. Let's say if we got 5.2 volts, the solar panel disconnects, probably 4.8, 4.9 volts, we reconnect the solar panel back. No idea how to do that. Is that going to involve maybe 2 relays, a transistor, a microcontroller, an IC? I don't know. I have no idea. Literally no idea. But that's the plan with the next video. I'll see you guys there. Take care. Bye-bye.